Hi, so my presentation is on the erosion of coastal regions. So who will this affect? The coastal region is one of the most heavily urbanised zones in the world, being home to 11 out of 50 of the world's biggest cities. In regards to recreational, environmental and economic importance, the world's coasts are a critical resource. Small changes in the size and direction of waves can cause serious disturbance to the coastline, enhancing erosion and modifying beach stability. Factors influencing coastal erosion. This chart shows how coastal systems are influenced by different processes. Even the meso and micro contributions, which are small in regards to the scale of the ocean, but they can still act as a strong control on the dynamic of our coastal systems. What causes sea level change at the coast? There are reasons to believe that coastal sea level change is not just an extension of open ocean sea level, but can be due to other factors. High-resolution ocean circulation models show that the satellite altimetry has found the sea level at the coast to differ from that of the open ocean. This can be a consequence of trapped Kelvin waves, shelf currents, or baroclinic instabilities. So, trapped Kelvin waves are waves in the ocean that balance the Earth's Coriolis force against a topographic boundary. And so here the boundary we're looking at is the coastline. A main feature of the Kelvin wave is that it's non-dispersive, so this means the group velocity will equal the phase velocity, and this results in it maintaining its shape as it moves along shore. And a shelf current is a current that's driven by cross-shelf pressure gradients, which will be created by a source of river input, so like the runoff from an estuary. Baroclinic instabilities can be caused by two layers of different pressure, which cause different wavelengths. How can the sea level be measured? Satellite altimetry measures the time taken for a pulse of electromagnetic radiation to travel from the satellite to the sea surface and back to the satellite, so a radar altimeter can map the topography of the ocean surface. However, there is a major limitation of altimetry, and that is the contamination of the signal in coastal regions, where the radar pulse will also be partly reflected by the land. So actually, if you're closer than 40 kilometres to the coast, satellite altimetry can be unreliable. How else can this be measured? So tide gauges can be used for the calibration of an altimeter, and tide gauges are fitted with sensors that continuously record the height of the surrounding sea level with respect to a reference height. How has wave power changed? Climate change within recent years has majorly contributed to the warming of our oceans. Wave power is defined as the transport of energy that is transmitted by sea-air exchanges and employed for wave motion. So since 1900, the sea surface temperature has actually increased by about 0.07 degrees Celsius each decade. And we can also see from this graph that the wave power has increased significantly, especially in the Southern Ocean. It has actually increased by about 0.4% per year since 1948. And with greater wave power, this means that the waves can cause greater erosion, seriously affecting coastal processes. But on a brighter note, the wave power energy market has been predicted to have an annual growth rate of 10.2% per year, as wave power can also provide renewable energy. But a big challenge of wave energy is the huge power the ocean holds, which can cause damage to equipment. A Finnish company called Wed Dec has designed a device called the Penguin. The Penguin is loosely anchored to the seafloor at a depth of 50 metres, with 2 metres of it visible above the surface. It works by using the movements of its asymmetric shaped hull, which rolls and heaves with each wave, to drive the generator and produce electricity. It is a massive device and weighs 1,600 tonnes and is 30 metres long, but they have said it is discreet and non-disruptive. Thank you for listening.